These are exercises from Reveal Geometry 5-2 on congruent triangles. The order matters when we name congruences. If we're told that triangle ABC is congruent to triangle DEF, the congruent statement is telling us that A is congruent to D, B is equal to E, and C is equal to F. The order matters. Also, segment AB is going to be congruent to segment DE, segment BC to EF, and AC to DF also. So in these examples, we want to basically identify the matching congruent parts of the triangles. So we can use the congruence tick marks and arc marks to match the angles up. So angle A is congruent to D. Angle ABC is going to be congruent to angle BCD, and so on, or DCB. And between the two triangles, BC and CB are two shared sides, so we call that the reflexive property. And also we can say that segment BA is congruent to segment DC. So we're matching up matching tick marks between the two figures. So this is helpful when we're given congruences labeled on the diagram. So we could say triangle ABC is congruent to, and then matching with A we have D, matching with B we have C, and matching with C we have B. The order matters. Matching vertices need to be in the same positions when we use the congruent statement. Now, number 2, we have parallel lines cut by a transversal, which gives us a couple of different pairs of alternate interior lines. We've got vertical parallel lines and horizontal parallel lines. So we want to name the congruent parts. By the third angles theorem, the other two angles at J and L are going to be congruent, since the two angles at J, at K and M, and that M and K in the other triangle are congruent. So by third angles, we can say those extra angles, those third angles are congruent. So we name the congruent parts. We've got JKM congruent to LMK, JMK congruent to LKM, angle J congruent to angle L. We can get away with one letter name in those. Segment KJ congruent to segment ML, segment KM congruent to segment KM, that's reflexive, and segment KL congruent to segment MJ. We want to name the triangle congruents. If we're going JKM, J to K to M, we have to go L to M to K to get the correct order to name the congruents. Looking at number 3, we have side links to match up the congruent sides. So we add, on the diagram, we add tick marks to mark the congruent parts. And then angles opposite those sides, we can also mark where the 30s go with the 30s and the 60s with the 60s, and then the right with the right, and so on like that. And now we just name the congruent parts. So angle X goes with angle A, because right angles are congruent. We could say that angle Z matches with angle C, and that angle Y matches with angle B. Now we can get away with only using one letter to name these, because there's no other angles to confuse things, no other vertices to confuse things. Segment YZ is congruent to BC, segment XZ is congruent to AC, and segment XY is congruent to AB. Looking at number 6 and 7, they're giving us figures that are marked as congruent. They're telling us that ABC is congruent to F to E, so A is congruent to F. So I can jump the 2x minus y over to the A. They're telling us that B is congruent to D. So 48 goes with Y. And they're telling us that C is congruent with E, which tells us that 108 goes with angle E also. So we can do triangle sums. and find out that x is equal to 36. And we can see from the given that y is equal to 48. And that's all we need for that one. We could also check it out. 2 times 72 minus 48 gives us 24. And 24 plus 48 plus 108 does equal 180. For 8 and 9, they're telling us that the polygons are congruent. So A goes with P, B with Q, C with R, and D with S. So I mark those with matching congruence marks. It helps me keep the figure in order. And we can see that 2x plus 4 is going to be 100, which is going to help us solve for x. And we can also see that between the three sides that 3y minus 3 is going to be equal to 12, which gives us that y is equal to 5. And then we can also figure out that x is going to be equal to 48. In number 12, they're giving us a couple of congruent they're giving us a couple of triangles. They're telling us that ACB, B is the letter in the middle, it's hard to see on the diagram, is congruent to DEB. The angles at B, the ABC angle and the DBE angle are going to be congruent because of vertical angles. But they ultimately want us to know the measure of DEB. So I'm going to draw an auxiliary diagram to kind of straighten these out, and then I'm going to mark them with the appropriate congruences. So C and B go together. Actually, C and E go together. And A goes with D, and B goes with B. And again, the two angles at B, those vertical angles there at B, are congruent to each other. So angle B is congruent to angle B between the two triangles. Now they want us to find the measure of angle DEB. So by third angles theorem, DEB is congruent to ACB, and ACB is the difference of 180 minus the 29 plus the 85, which comes to 180 take away 64, which comes to 116 degrees. So that's the measure of angle DEB. In number 13, Mr. Lewis is building a rustic dining room table. The main idea here is we have a couple of congruent triangles at the bottom, and they give us the congruences, so we mark the congruences in order. And if RPG is 49 degrees, angle VTU is also going to be 49 degrees. So 90 and 49 gives us 139. Take away from 180, we get that 41 degrees is the measure of angle R, and 41 degrees is also the measure of angle V. They wanted us to find the measure of angle TVU, which is the same as angle V. For these, we want to draw and label a figure to represent the congruent triangles. It doesn't have to be to scale. What we want to do is try to draw a couple of triangles that look like they could be congruent and label the corresponding parts with what they give us, and then answer the questions. So ABC congruent to DEF, I make A match D, B match E, and C match F. And then I'm going to put the labels in for the different side lengths. We have like 11 plus x is equal to 3x minus 13, so we could set those equal to each other to find x. And then they tell us that DE is 2y minus 5, but that's also equal to 7, so we can find out that y is equal to 6. And then x, when we solve the other equation, x comes out being equal to 12. For number 20, we're going to draw two triangles, LMN and RST. I try to put the vertices in matching locations between the two triangles, try to make them look like they're in the same shape. Then I'm going to put the information in that they're giving us in the word problem. We end up with 10y matches 70, so y is going to be 7 for that one. Now we have to find x. Using triangle sums, we can figure out what the measure of angle n is, and then that's going to equal to 4x plus 9, which is its matching angle from the other triangle. Yeah, matching congruent angle. So 4x plus 9 is equal to 61, which gives us x is equal to 13. So y is equal to 7, x is equal to 13. For 21, I'm going to draw another couple of triangles. JKL is going to match with MNP. Then I'm going to label the congruent parts and put the given information in. So 2x minus 3 is going to be equal to 5. And y plus 4 is going to be equal to 2y minus 15. So I can set those two together and solve for y. And I can set 2x minus 3 equal to 5 and solve for x. So x is going to be 4 and y is going to be 19. Number 25 is a proof, so we need to supply the reasons for this. They're giving us a couple of triangles. They're given that angle P is congruent to angle X and angle Q is congruent to angle Y, and they want us to prove basically the third angles that angle R is congruent to angle Z. So we start with our givens for step 1. By definition of congruent, we can say that those measures of those angles are congruent to each other. And then by triangle sums, they all have to add up to 180 degrees. Then I think we're going to do a substitution. And 180 is equal to 180, so we're going to substitute in number 3, the first one equal to the second one. And now we can substitute between 2 and 4. And then we can subtract off the equal parts. And we're left with the measure of angle R is equal to the measure of angle Z. And since the measures are equal, we can say that those angles are actually congruent. So there's a short proof of the third angles theorem. For 28, we want to find the error. So the best way to do this is to mark the congruent parts between the two triangles and then look at their congruent statements. So Jasmine says that CAB matches. So C is the side between the 2 and the 3 marks, and Z is the side between the 2 and the 3 marks. That matches. Look at Y and A. A is 3 marks. Y is also 3 marks. So it looks like Jasmine has her statement correct. Wes says that ABC is equal to YXZ. If we look at A does match with Y. B and X, though, B does match with X. And C matches with C. So they're both correct. The orders were different for both, but they had the right-hand congruence in the same matching order as the left-hand congruence. So there's several different ways to name congruences depending on which vertex you want to start with. Looking at number 29, we want to justify why the orders of the vertices is important. So we just kind of show with an example, like ABC versus DFE. If we name it in a different order, like ABC compared to EFD, angle A does not match with angle E. Angle B matches with angle F, but angle C does not match with angle D. So that's a false congruent statement. For the bottom one, we want to find the measures of those. We have 90-degree angles. They're going to be congruent, and that's it.